Hey, hello everybody. So today we're just going to go through with the first part of a hydrostatic chapter. So in this chapter we have like the 5 topics. The first one we're just going to discuss about like the fundamentals, fundamental quantities in hydraulics and fluid mechanics, and concepts of the physics, like for example some terms like the pressure, weight, forces, and mass, and density and relative density. Then in the second section, we're just going to move on to hydrostatic pressure and force. Third, we're just going to go through the force on plane, vertical, immersed surface. And then later in the fourth section, we're just going to look at the location of the resultant force on a vertical surface. And the fifth section of chapter 1, we're just looking at the force, how we're just going to work on a plane, incline, and immersed surfaces. So just let's look at the first section of this chapter. So let's start with some basic definitions of the pressure and force. So imagine we got like the one person that is going to wear stiletto heel or trainer. So for example, if that person wear stiletto heel and try to just walk through a soft wooden floor, we're just going to see the level of the damage of one's wearing the stiletto heel is much worse than the time that the same person is wearing the trainer. So what's the reason for that? So the reason of that is the difference that we're just going to look at, the difference between the pressure. Although the same person with the same weight or mass of body we have different pressure. If you look at the formula in more detail, pressure, we have the formula pressure P is the ratio of force to area. So in here, force is denoted by F divided by A. So the P, the pressure, is equal to F over A. And the unit for that in SI or metric unit is called Newton per square meter, or Pascal, which is an acronym with the name of the person who created like the formula of the pressure. So if I look at this formula in more detail and in general term, actually, we have the formula, the second Newton law is the F is equal to M times A. So F is the force, the unit is Newton, is equal to M is the mass with the unit of kilogram times area, which is acceleration, meter per square second. If we assume that we're just going to have like the free wall, for the free wall situation, F, the force, the force that we have is the weight, the weight towards downside. That is equal to M times G. G is like the gravity acceleration or acceleration of gravity. So the W is equal to mg. So that's the situations that we have. So the other like the term that we're just going to just look at this is the density. Density is the ratio of the mass over the volume, and denoted by rho is like a Greek letter, is equal to M is denoted by for M divided by V is denoted for volume. And in the SI units, we have the unit of the density, kilogram per cubic meter. So that is like they call density. But if you're just going to say density, we're just going to see the difference between two like the different like the bodies. For example, 1 cube of water, which is size of like 1 meter, you can see it's like the, for example, density is like 1,000 kilogram per cubic meter. And but if it might be the same weight with the equivalent mass of the car, but the density of the car is like much less than the density of the water. But the weight might be the same, but this is more denser. That's the situation. And the other thing, so the mass density is denoted by rho, as we said in here. However, we have another like a term is called weight density or specific weight. That is the rho or the density times g, gravity acceleration, which is denoted by W, lowercase w. W is rho g, or the weight density or specific density. The other term that we normally have is called relative density or specific gravity. Specific gravity or relative density is the ratio of the density of the solid or the body to the ratio to the density of the water. So the density of the solid to the density of the water is called relative density or specific gravity. So that's a fundamental concepts and fundamental quantities in hydraulics that we need to just go ahead. In the next section, I will just go through with some basic definitions of hydrostatic formula. And for that one, please just watch the next video.